So, question 12. A cone has a radius of length 18 centimeters and a height of 16.25. Find its volume. Okay, the volume's easy. What's the volume easy, guys? You have everything you need, don't you? So it's a 1/3 pi r squared, 18 squared times h, 16.25, and what you get? Anybody got the answer for me? Give it to me in decimals because I don't think you need it in terms of pi this time. $5513.5, call it. Yeah. All right. Now the next problem is we haven't got the slant heights. So what you're being given here is you're given a cone, and that cone. Box that up. There you go. Not so bad. So there's your cone. Now you're given the radius, but you're not given the slant edge. So how do you get the slant edge? The slant edge being a represent. Yep, thank you. Pythagoras' theorem. So what do we get here? 18 and 16.25 L here. So L squared equals what, Sam? Do Pythagoras. Yeah, but L's the hypotenuse, so equals the other two sides squared and added together. Now use your calculator and square root it. The longest side is the C. That's called the hypotenuse. Because that's in a cone, the slant edge is called L. Yeah. Yeah. What'd you say, Oscar? Yeah, I believe so. Oh, sorry. In the first one, it says not to use the pi button, but to use 3.14. Oscar, what you get instead should be roughly the same number. 5. Oh, perfect. Sorry, guys. So you can see the difference between the two pi values there. One of them slightly off. It does there, Sam. See? Oh yeah. You'd be open to misinterpretation there, so they won't punish you too harshly. Now, 16.25 squared plus 18 squared is 588.0625. Square root that, and what you get? 24 points. All right. Does anybody know the curved? It wants the total surface area, not the curved surface area. Curved surface area is pi r L. And the curved surface area is the fan part. I botched that, sorry. We'll go again. The curved surface area is the fan part. What do I have to add on to the fan part? Have to add on a? Lads, to get total surface area, we have to add on a circle, don't I? For the base part. Do you know when you have a cornetto? That little cardboard circle you take out of the cone? That have to add on that part. So it's going to be pi r L plus pi r. So, and I have to use 3.14, isn't that right? And my radius is 18. And is it 24.5 or 24.25? 24.25. And then I have to add that onto a circle. What do you get, lads? Any takers? 3,387.97 centimeters squared area. All right, so question 14. And what we're going to do here, guys, is the trick to these ones is that they're similar triangles. So what I mean by that is, see this one here? And then do you see this triangle I'm about to mark here? Now, here's the trick we're going to use. And I'm just going to grab this full question and bring it underneath. Okay, now what happens is, it says it's a height of 14 and a radius of r. So that's 14 and the radius is r. And then it says you cut a cone off the top, and the cone you cut off the top is height 10.5 and radius of 3. First of all, which one's the bigger triangle? Top one. How much bigger is it, is what you really want to know. So what's 14 divided by 10.5? Is it? In fraction mode, I'd say probably the best bet. 4/3. So the big one is 4/3 times bigger than the small one. So what happens when you multiply 3 by 4/3? What should happen? 12/3, which is 4. This means the radius is 4. We now know what the size of the big cone is compared to the small cone. Does that make sense? They're in the same proportion. Okay? So we know that this is 4 and we know this is 3. Write down the radius r of the cone. We got that. R equals 4. Find the volume of S. Which one's S? The large one, isn't it? And we have to use 3.14. So it's going to be 1/3. 3.14 is pi. Radius squared is 4 squared, and height is 14. Anybody get that out? Yeah, awesome. Okay. Next thing we got to do is find the volume of the full frustum, otherwise known as this part here, the green part. And what can we do to get the area, to get the volume of the green part? Get the volume of the yellow cone and take it away from the volume of the large cone. Does that make sense? What's left over is the green bit, because the yellow and the green bit added together give you the full cone. Okay, so what's the area of the small cone then? Yeah, I'll do it now. So it's 1/3, 3.14, radius is 3, and height is 10.5. And what did you get? 98.91 centimeters cubed. The full cone, take away the yellow cone, leaves you what? Yeah. 135.59 centimeters cubed. All good? Who got that one now? All right. Did you get it? Yeah. Egg timer consists of 2 identical cones of height 6 centimeters and base radius 4 centimeters. Sand occupies half the volume of one cone and flows from one to the other at the rate of 4 pi over 45 centimeters cubed per second. Calculate the volume of each cone in terms of pi. All right, guys. They're both the same cone, aren't they? So this is 4, and this here is 6. So what's the volume of this cone, lads? Easy money here. Anybody got a number for me? 332 pi. 32 pi. Now, lads, so what happens is, if I fill the top cone completely full of sand, okay, and what happens is the sand starts to flow into the lower cone, okay? So what a better way of doing this question is, okay, sorry guys, we call this the simplistic method, right? It's where you make something really simple on yourself. If this was 10 liters, sorry lads, if this was 10 liters and the sand flows at 1 liter per minute, how long would it take to fill 10 liters? You divide the volume of the container by the rate of flow. We do the same thing here. 32 pi gets divided by 4 pi over 45. You can enter that into your calculator just by using the fraction button first through 2 pi. Now it's very important you go to the bottom first and then you do the fraction. 4 pi, press the fraction button again over 45 and you get a result of 360 seconds. Is that right? And you're done. Did I give you anything else? So what did we do? 12, 14 and? Alright.